What's going on, guys? Welcome back to another video. Now, I know I haven't posted for a while, and that's because I've been quite busy lately, and I've actually been working on my second RoboCup project, which I actually won with my team, so that was great, and I'll be uploading a video about that really soon. But anyway, today's video is about this small drift car that I made. Here, if it focuses in, there we go. So for a while now, I've just been wanting to make like a really small RC car, and I've just been watching lots of videos of these people that make Hot Wheels cars into RC cars. So I wanted to give it a go myself, but I didn't really have all the proper parts for it. So although I didn't get RC into this, which I might add in the future, I actually got it to drift and stuff, which turned out really great. I've got some cool videos of that. Sad part is, it stopped working. I'm not exactly sure why, but it seems to be something wrong with the steering's control board. But I can fix that later. But for now, let me show you how I made it. Alright, so there were a few main parts for this car. So the first thing is obviously like the main base, the chassis. And then there's the steering. And there's the motor at the back. And obviously you've got like the electronics, like the servo, the motor, and the battery and the controlling board. Alright, so the first thing I made was just the chassis, which was just made out of a piece of plastic that I cut out from my old phone case which I had. Then I moved on to the motors at the back. So I don't know if you can see here, but this is actually made from one of those servo motors, and what I did was I basically just took out all the gears, cut it to the size so just one axle goes through, and basically there's one long metal rod connecting these two wheels that goes through this. Then there's like a big gear connected to a smaller gear which is connected to a motor. Now I can't actually show you guys because obviously it's inside there, but I might be able to give you a shot of what it looks like in a normal servo motor, and that'll kind of give you an idea. Alright, right here I have the parts inside a servo, and I've just taken apart because this is the one where I took the IC from. Now, as you can see, it's got a very small potentiometer that just connects inside. I don't know if I'll be able to fit it in. Okay, there we go. Now, if I take the top off, you can see there are like lots of gears. So what I've done is I've taken all of these off and I've just kept these, which means I can cut off anything on this side. And basically, that's how I got the gear ratio, because there's a really small gear connected to the motor, and then this one is free spinning. And as you can see, it's not going through both sides, so I just got a longer axle, drilled a hole in the bottom cap, and then I just put the axle through there, and the wheels fit perfectly on top because like I just drilled a hole in the wheels. Now, one more thing I had to explain with the servo was how the potentiometer works. So as you can see, it's right there, and it basically connects to the final gear through here. And basically what happens is, let's say I want to write 180 degrees to the servo again. Basically, that signal gets sent, the motor starts spinning, and when the top part spins, this gear, it spins a potentiometer, and then the potentiometer knows it's at 180 degrees, for example, and that's when it stops. Now, the further it is from the further the current position is from the desired position, so like let's say if it was at 0 degrees to begin with, and we want it to go to 180 degrees, well, it would spin faster because the error is bigger. And that's how you can change the speed with the hack that I showed you before. Because basically you fix it at thinking it's at 90 degrees by having a voltage divider with equal voltages, which basically just simulates the potentiometer in the middle position. So then anything greater than that is one direction, and anything below that is another direction. And the further you get away from the middle, which is 90, you get more speed. And yeah, so that's basically how I hacked the servo motors. For the steering, I literally just used like old servo arms with some wires And yeah, that's basically how I made it. And I just used like plastic bits I had for like spacing, and just the screws from the servo that I opened up for the to attach the wheels on top. And if I just zoom in, you should be able to see like the little metal spirals, like coils almost. So I just made those using some wires so that the wheels can turn on that axle, and there's a little arm connecting to this piece of metal that connects to the servo motor. Now with the servo motor, because I didn't have like a small one, what I did was I had this motor with a worm gear and then the gear for it. Now I've connected that to a really small potentiometer, as you can see from the side, the black thing, and that's connected to the control board of a servo motor I took apart, and that basically just acts like its own servo motor. And there are some videos that I've got that I'll show you that where it was working completely fine, but recently it just stopped working. I have no idea why. Now for the motor, because it is from a servo motor, I've had to hack the like the PCB that comes with the servo motor. So the part where the potentiometer is usually connected, I've soldered a voltage divider onto there, and it just got equal resistance on both. Now what that does is it basically simulates the servo being in the middle position, and then basically when you give a control signal, for example, I don't know, let's say 180 degrees, it'll go in full speed in one direction, and if it's at 90 degrees it'll stay where it is, because that's where it thinks the potentiometer is, the position. And just like that, you can control it in two directions. So that was a cool little hack that I'll keep on using if I make more of these. Now for the control board, it would have been better to have an RC receiver if I wanted to control it. And right now I just had an Arduino Nano, so that's what I used. And as you can see, it's quite big, probably too big for the car, but I've had to make use of what I had, so that's all good. And the last part is just the battery, and luckily I had a decently sized one that worked for this. And that was basically it. And for the wheels, I just got it from an old Hot Wheels I had lying around. So yeah, it's pretty cool. Like, most of it's just repurposed, and I've just had to do a lot of customization in this project. It's not just connecting the electronics together, but actually making them. So yeah, now let me show you how it actually works.